Hi guys, so today I'm going to explain to y'all how I did my problems for our written exam for Module 1. So let's start with number 1. So for number 1, we are supposed to place the digits 8, 10, 11, 12, and 13 in the circles to make the sums across and vertically equal 31. So is there more than one answer to the puzzle? We are supposed to show all possible combinations of numbers to prove how many combinations exist which meet the rule of 31. So for part A, I found that there are 4 possible combinations, as you can see right here, that all equal 31 across and down. For part B, I also used the guess and check method to find the missing numbers, as you can see. Now let's go down to number 2. So for number 2, 9 square tiles are laid out on a table so that they make a solid pattern. Each tile must touch at least one other tile along an entire edge. So we are supposed to sketch all possible figures which can be formed and calculate the perimeters. So I found and sketched 5 tiles and wrote down each perimeter for each one. So for this top one, the perimeter is 20 units. This one right here is 16 units. The perimeter for this one is 14 units. The perimeter for this one is 12 units, and the perimeter of this one is 14 units. And for part B, we are supposed to figure out which one is the least perimeter and which one has the greatest perimeter. So this rectangle right here has the smallest perimeter, which is 12 units, and the top one has the greatest perimeter of 20 units. Now let's go to number 3. For number 3, we are supposed to draw a diagram for each possible path from A to B, and it must only move upward or to the right. So for this problem, I used Pascal's triangle, and there are only 6 rows in our triangle, as you can see. And the bottom row, middle number is 20, so that means there are 20 paths from A to B, only moving upward and to the right. For part B on number 3, we are supposed to draw each possible path from C to E. So I found out that there are 4 possible paths from C to E, and I wrote them down right here. Number 1 is C to B to E. Number 2 is C to A to B to E. Number 3 is C to F to E. And number 4 is C to F to B to E. Now let's go to number 4. So for number 4, the figures to the right show an addition pyramid in which each number is the sum of the 2 numbers immediately below. So we are supposed to write an equation to solve each pyramid and show each step used to solve our equations. So for A, it is clear that we must find 3 numbers, A, B, and X. So A plus B equals 25, X plus 7 equals A, and 7 plus 3 equals B. So 7 plus 3 equals 10. So since B is 10, A plus 10 equals 25. So A must be 15. Since A is 15, X plus 7 equals 15. X must be 8 because 8 plus 7 equals 15. And now we have found our solution. 25, 15, 10, 8, 7, and 3. And I solved B and C just like this. We can look at C really quick. So for C, I used the guess and check method again. And we must find 3 numbers again, A, B, and C. 2 plus B equals Z. B plus 9 equals A. And Z plus A equals 27. So, since we're using the guess and check method, suppose that we guess 8 for B. This would mean that 2 plus 8 equals Z, which equals 10. 8 plus 9 equals A, which is 17. And now we have to check to see if Z plus A equals 27. So 10 is Z and 17 is A, which equals 27. So we have our solution. So for number 5, we are supposed to use the table to figure out who is married to whom. And we have a couple clues that they give us, which are Floyd is Josie's brother. Josie and Gus dated some, but then Gus met his new wife. Kitty is married to Will. Anne has 2 brothers, and Anne's husband is an only child. So I used the process of elimination to figure out who is married to whom. Floyd and Josie are siblings, so that means they are not married, of course. Kitty is married to Will, so we can mark Will off of everyone else's list. So that must mean that Josie and David are married, so we can mark David off of everyone else's list also. Anne and Gus must be married, since our clue is that Anne's husband is an only child and Floyd is not an only child. That leaves Sarah and Floyd, so they must be married. Now let's go to number 6. So for number 6, we are supposed to consider these 3 different trapezoidal numbers, where n is a positive integer. So for part A, we are supposed to create a dot pattern representation of the trapezoidal numbers. Sorry, it's kind of hard to say that word. So for this one, it is 3 dots because it equals 3. And for this one, 1 plus 2 plus 2 plus 2 plus 1 equals 8. So there is 8 dots, and it looks like a trapezoid. And for this one, 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1 equals 15. So there are 15 dots in this trapezoid. For part B, we are supposed to show how the dots in a representation of a trapezoidal number can be rearranged into a rectangle with 2 more columns than rows. So instead of it being in a shape of a trapezoid, we have to make the dots in a shape of a rectangle. As you can see right here, I made all 3 numbers in the shape of a rectangle. And for C, using inductive reasoning, show what general formula gives the nth trapezoidal number. So the formula I found is n parentheses n plus 2. Thank you, guys.